from standard form to scientific notation, where we put the decimal after the first whole number. We shift to the right. We keep track of the loops because the loops become our exponent, right? So we did this for very large numbers. So we're going to turn this paper sideways and write large values. This is the process for large values, which means we also need to have a process for small values. So that's this one that says standard right here. Large values. Over to the side.
Do any of you know the actor Ben Stiller? Alex the Lion, Larry Daly, Cockapoo.
What are you talking about?
All of Ben Stiller's roles from movies and TV shows.
Zoolander?
What?
Isn't he Zoolander?
Zoolander? From what?
He's like, he thinks he's a model. It's him and Will Ferrell, I think. Isn't that Zoolander? Maybe? I don't know. He's got a lot of good rules. Hey. So now we're going to finish up these notes. Today we're going to convert for small values.
Wait, is this the blank page?
Yep. So this is the blank paper we just took out. And now we're going to do the same thing, standard to scientific, but with small values.
So do you write standard scientific on the top, right?
No, it's just an extension of yesterday's notes.
Is it just on the back page? No.
No. Some of these lights are not dimming. Like, doesn't that look really bright over there?
This is like really bright. Oh my lord.
And that one over there. Can we turn them off?
Yeah.
Yay, yes.
That feels so
Or just like that just so much better.
Hello.
Okay. So we're going to keep track of our steps here. We have example number 1. And we're going to start with a really small value. I know it's a small value because it has a decimal at the beginning and a lot of zeros in front of the whole number digits. So step 1 is to place a new decimal after the first non-zero digit. So we're going to put that right there in between the 6 and the 2. A new decimal in between, right after the first non-zero digit. Step 2 is to create loops to put my decimal right here again, and then now I'm shifting the loops to the left. And I still know that there are 6 loops. That helps me out. Yes.
Couldn't you just like skip step 1 and just do the loops?
So
Because when you still get
this is just me like writing out all the steps so you can see the process. And the next 2 examples we do, I will not be writing out the steps. We'll just do the process.
But would still when you're doing it like on your own, step 1, it says step 1 new decimal. Wouldn't that be just not really needed?
Yeah, you have to know where to start your loops. You have to put your decimal there to know where to start your loops to move to the left.
What if it
Or
uh,
the way I see it is when it says create new loops to move the new decimal to the front, you could do the decimal and then move it to the first non-zero digit.
So there's a reason we're doing it this way, and I'll tell you about it in just 1 second. I see what you're saying, but there's a method, I promise. Method to my madness. Okay, so I have 6 loops here. What is this going to turn into? Delaney? The exponent. However, because I moved my decimal to the left, I know that my exponent is going to be negative, right? So when you put your decimal and you move it to the left, negative exponent. Previously, we put our decimal and we shifted it to the right, positive exponent, right? I'm sorry?
Left and right. Yes, this is.
We're moving this to the left to count our loops. We count our loops to the left, this one, negative exponent. On the previous one, we counted our loops to the right, positive exponent. Go look at it. It's right there. I know you guys wrote it down yesterday, right? So which direction we move our loops tells us positive or negative exponent. So step 3, write the value. In scientific notation. So I know it's going to be something times 10 to the negative 6. Again, that's a negative because I counted my loops to the left, right? And on a number line, the values to the left are negative. Negative exponent. Values to the right are positive. Positive exponent. So what will I have here in front of the times 10 to the negative 6? Emma?
6.2.
Yep. And that is the number written in scientific notation. How can I check my work? How can I check my work? In theory, you should never miss these conversions because I can check my work. What can I do? Molly?
Calculate all.
Nope.
You just do the scientific notation.
I'm going to convert this back into standard form. What should it be? The number I started out with, right? If you convert it and it's not the same number you started out with, then you've made a mistake somewhere. Okay, so let's do another example. 0.000506. Where will my decimal go? Lily McNew, where's my decimal going to go? Behind the 5. And then I'm going to create loops to move that to the front. I have 4 loops. So I know my exponent is going to be a -4 because my loops went to the left. So what will the first part be? I know I have 10 to the -4. What will go in front of 10 to the -4? Molly?
5.06.
5.06. All right, this last one proves my point as to why we need scientific notation. All those zeros can get kind of confusing to keep track of. There are 7 of them. Beautiful. Where will my decimal go? Where? So you want me to put it here? Or here? Camera 1, camera 2. It's going to go after my first non-zero number. So it's going to go right here. I thought you said before the 7.
Oh, no, I said in front of the 7.
Right, this is still not in front of the 7. Right, this is the back of, like this would be behind the 7, right? But that's what you were talking about, that spot right there? Okay, perfect. Yeah. Okay, so then I'm going to move my loops. I have 8 loops. The loops went to the left, so I know it's going to be times 10 to the negative 8. What will be in front of times 10 to the negative 8? Delaney? Excellent. Okay, once you have that done, let's do some of this coloring page together. Yep, you can put that in your binder. We'll do table of contents here in a minute. Okay, we're going to start converting standard form to scientific notation. Where does my decimal go? So Nick, go ahead and put your iPad away. Where will my decimal go for 380? This is one of those large values. Kaylee? Behind the 3. I moved 2 loops to the right. So that tells me it's going to be a positive exponent. So what will my scientific notation be for this? Yep, 3.8 times 10 to the second power. I moved 2 to the right. Exponent is positive. Then I'm going to find that here in my grid. 3.8 times 10 to the second power. I'm going to color accordingly. Okay, Stephanie, where will the decimal go for this next number? It's one of those large values. So where will I put the decimal to get started? Sure is. Put my decimal here. 1, 2, 3, 4, 5, 6 loops to the right. What will the scientific notation be? Emma? 5.97 times 10 to the 6th. Thank you. Okay, so this is considered a small value because it already has a decimal in it. So I'm going to put my decimal, my new decimal behind the 4. I would move it 1 to the left. 4 times 10 to the negative 1 because I moved the loop to the left. It's right up here in this corner. Oops, I forgot to color the other one in too. This was all the way filled in down here in this corner. Molly, do you have a question?
Yeah, where is the whole one related?
Right down here in this corner.
No, I'm the one that we just did.
Right up here.
We love you, Mrs. Marsh.
Aw, thanks, Nick. How about this next one? Super small value. Where will the decimal go? Where will I put it? Delaney? After the 3. My loop goes to the left, so I know it's going to be a negative exponent. What will I multiply that by? Who's hiding from me? Chloe? 3.8, thank you. That one is right here.
Does that not annoy you?
Does what not annoy me?
The way that the colors are, like in your colors, some colors go down and some colors go sideways.
No, does it bother you? I'm sorry.
Like this one,
Like this one right here, this bothers you, doesn't it? Because those are vertical and those are horizontal and diagonal.
like the full ones.
Mm-hmm.
This one is cross, some are down, and some are cross.
Yeah.
It just annoys me so much.
I'm sorry. Okay, I want you guys to do these next 4 by yourselves. So stop right here. I want you to do the next 4 all by yourself. I have all the confidence in the world that you guys can do those 4 if you haven't already worked ahead.
Oh boy.